Hi, my name is Lee Ko. I'm the Human Interface Marketing Manager at Microchip.
The system in demonstration consists of the PICDEM TouchSense tool board and the window-based Diagnostics tool. The PICDEM TouchSense tool board has 4 different sensor demonstration areas with a total of 29 keys and a slider. It has directional keypad at the bottom and display at the top, numeric keypad, linear touch slider, soft power control. At the back of the TouchSense tool board, you can see that it is controlled by the PIC24 FJ256GB110 microcontroller. This 16-bit MCU has the USB on-the-go, 16-channel CTMU, and other peripherals. As you can see here, the CTMU drives the capacitive touchpads directly. The window-based diagnostic tool used is the MTouch Diagnostic Tool version 2.1.3 that comes with the board or available for free download at www.microchip.com/mtouch. First, connect the USB cable to a USB port on the PC, then to the board. The PC USB connection provides power and communication to the board. In standalone mode, when a key is touched, you will hear a beep sound and a corresponding LED turned on. The slider shows the level where you touched last. In diagnostic mode, launch the MTouch Diagnostic tool from the PC. The tool launches with 2 windows, the small board window and the bigger diagnostic tool window. Select the MTouch 2 tab of the board window. For the purpose of demonstration, I am selecting the numeric keypad section in the board window. The diagnostic window is now displaying the status of the individual sensors and channels for the numeric keypad section of the demo board, with display for the 4 rows R1 through R4 and 5 columns C1 through C5. Each bar consists of the following information: a vertical bar that indicates the instantaneous conversion voltage value, an orange horizontal indicator that indicates the moving average of the touch sensor, a blue horizontal indicator that indicates the hysteresis value for the touch sensor, and finally a green horizontal indicator that shows the trip level. Next, I'm touching the key 7. Notice that the instantaneous voltage value falls below the trip level. The software detects the touch by highlighting R1 and C2. For diagnostic purposes, you can adjust the trip point of R1 and C2. For example, by left-clicking the vertical bar, our R1 setup window appears. I can type in the trip level to 726. I do the same for C2 and I type in the trip level to 729. Now, when I touch the key 7, because the voltage value doesn't cross the trip level, the software doesn't detect the touch. Therefore, R1 and C2 are not highlighted. Now, if I cover the key 7 with more area on my finger, it detects the touch. This way, the application can be easily tuned for soft touch or hard touch. I can also have an option to record the conversion value of C2. Within the C2 setup window, there is a Chart C2 button. When the button is pressed, a new window appears and displays a plot of the channel's conversion value versus time, and plotting of data begins immediately. When I touch key 7 again, you see that the conversion value drops and being recorded. When I release the key, the conversion value goes back to normal. The above are some of the diagnostic examples you can use with the tool. There are many other features on the board and diagnostic tool windows you can use for debugging and development of the capacitive touchsense solution.